Dear students, in this lecture we will talk about symmetry in crystal. So, first of all, we will discuss what is crystal symmetry. So, symmetry in crystal. When crystal is rotated about its axis, it shows the same appearance. This is known as symmetry. All crystals shows a various type of symmetries. So, all crystals of the same substances possesses the same element of symmetry. Each arrangement of atoms has a certain number of elements of symmetry. That is, change in the orientation of the arrangement of atom seems to leave the atom unmoved. Now we will discuss the elements of symmetry. There are three types of symmetry elements in the crystal. That is, center of symmetry, axis of symmetry, and planes of symmetry. First of all, we will discuss the center of symmetry. It is defined as any imaginary point within the crystal such that any line passing through this point and intersect the opposite faces of crystal at equal distance. Or, center of symmetry can be defined as any line drawn through this point will intersect the surface at equal distance in both directions. That is, like we have this figure, that is cubic symmetry. This one is the tetragonal symmetry, and here you can see that this one is the center of symmetry. All lines passing through this point, that is this one, and this one line, all lines passing through this point will intersect the opposite faces at equal distance. As you can see, like for example, this one line which is passing through this center of symmetry and it intersecting this one face and this one face at equal distance. And here you can see that this one is the one face of the cubic crystal. Here you can see that this one is the center of symmetry, and this line and these two lines which are passing through this point and intersecting this face into two equal distance at opposite faces. And here this one is the tetragonal symmetry. Again, here you can see that this one is the center of symmetry, and all imaginary lines which are passing through these points intersecting this tetragonal cubic crystal into two equal parts at equal distance on the opposite sides. Now we will discuss the planes of symmetry. It is an imaginary plane which divides the crystal into two equal parts such that the one is the mirror image of other. For example, regular cubic crystal structures can have 9 planes of symmetry. So the cubic crystal structures have the 9 planes of symmetry which divide the crystal such that one part is the mirror image of other. So in 9 crystal planes, the 3 planes of symmetry are parallel to the faces of cube, and the remaining 6 diagonal planes are passing through the opposite edges of cube. Here you can see that these are the cubes, and so this one is the plane that is the parallel to the faces of cube, that is it's parallel to this face and this one face. So this plane, here you can see that on both sides of this plane, the crystal is the mirror image of each other. This one side and this one sides are equal to each other. So this plane, that is the parallel to both this one face and this one face, dividing the crystal into two parts which are mirror image of each other. Let we have another parallel plane, that is this plane parallel to these two faces. So this plane again dividing this cubic crystal into two parts, two equal parts. This upper part and lower parts are mirror image of each other, that is both are equal in symmetry, both having the equal shape. And this one, this is another parallel plane, where you can see that is dividing the front and back face of the crystal, that is dividing the crystal again into two mirror image part, that is the both parts are equal in symmetry, and this plane is parallel to this one face and the face that is behind this plane. Now we discuss the diagonal planes passing through the opposite edges. Here you can see that this is again cubic structure, and this one is the plane, that is the plane passing both these opposite edges. Again this plane is dividing the crystal into two equal parts, and both parts, this one side and this one sides, are mirror image of each other, both again having the same symmetry. So this diagonal plane again dividing the crystal, and both parts on both sides of this planes are mirror image of each other. Now we have another diagonal plane, and so this plane again passing through these opposite edges. So this is the parallel to, that is the plane passing through these edges, again it dividing the crystal into two mirror image part. So this one is another cube, and this one is another plane, diagonal plane, that is passing through this one, both these opposite edges. Again both sides of crystals are mirror image of each other. We have another cubic structure. This is another plane, diagonal plane passing through opposite edges. Let's another cube, and like this one is another plane, that is the diagonal plane passing through opposite edges and dividing the crystal into two mirror image part, both parts having opposite sides, having the of this cubic crystal having same symmetry. So this one is another sixth one, diagonal planes. So again this diagonal plane passing through opposite edges and dividing the crystal into two equal parts which are mirror image of each other. So the cubic crystals have the 9 symmetry planes, of which the 3 are parallel to different faces, and these planes are, which are the diagonal planes passing through the opposite edges. All these are the symmetric planes. All these planes divide the cubic crystals into two equal parts which are mirror image of each other. Now another symmetry element which is called as axis of symmetry. So the axis of symmetry can be defined as, the axis of symmetry is the line about which the crystal may be rotated and present the same appearance more than once during the complete revolution through 60 degrees. So one complete revolution is of 60 degrees. So we can rotate the crystal about the axis of symmetry, and we get the same appearance of that crystal. When we rotate the crystal to certain angle, around the axis of symmetry, and we get the same crystal symmetry. This is called as axis of symmetry, which about which when crystal is rotated and it presents same appearance. So if the crystal presents the same appearance and time during one complete revolution, the crystal is said to be n-fold symmetry. So it means that total one complete revolution is of 360 degree. We can rotate the crystal by 90 degree or by 120 degree or through 60 degree, and we get n time. We get the same appearance during the one complete revolution. So for example, the cubic crystal of sodium chloride has 13 axes of symmetry, of which 4 are threefold and 3 are fourfold and 6 are twofold axes of symmetry. Now let's discuss how we can understand these axes of symmetry. We have this hexagonal shape and it has six-fold axis of symmetry. Like when we rotate these crystals about 60 degree, and so 360 divided by 60 is equal to six-fold. So this structure, this hexagonal structures has six-fold axis of symmetry. So we rotate this hexagonal structure 6 times about 60 degree about this axis of symmetry, and we get the same appearance 6 times. So this is called as six-fold axis of symmetry. This structure, this hexagonal structures, is said to be six-fold symmetric structure. Let's we have the cubic structure. When we rotate this cube through 90 degree through this axis of symmetry, this is the axis of symmetry. This line is called as axis of symmetry. When we rotate this cubic structure about 90 degree, and that is 360 divided by 90 is equal to fourfold. So when we rotate this cubic structure through 90 degree 4 times, we get the same cubic structure. So this is the fourfold cubic structure, that is upon 4 rotation we get the same crystal structure once again. We have the cubic structure, and when this one is the axis of symmetry, and when we rotate this cubic structure through 120 degree about this axis of symmetry, and when we rotate it 3 times, that is 360 divided by 120 is equal to threefold. When we rotate this structure through 120 degree 3 times, we get we get the same appearance. That is, again we get the same cubic structure in the same symmetry. So this, when we rotate it through 120 degree, then through about this axis, so this axis is the threefold axis of symmetry. So when we rotate the crystal 3 times, we get the same, again we get the same appearance. We have another axis of symmetry. This one is axis of symmetry. When we rotate the crystal through this axis through 120 degree, and then that is the 2 times. 360 divided by 180 is equal to twofold. So this axis of symmetry is the twofold axis of symmetry. That is, when we rotate the crystal through this axis 2 times, then again we get the same appearance of this crystal.